Hey everyone, here's our math problem for today. Let's say we are given a times b equals 200, b times c equals 700, and a times c equals 800. All of these variables a, b, and c are real numbers, and we are asked to find the value of a squared plus b squared plus c squared. You can pause the video and see if you can solve this algebra challenge. Now let's solve this problem together. Our first step is to represent each of these as a times b times c. So let's take a look at this first equation. Multiply both sides of this equation by c to get a times b times c at the left, and the right side is 200c. Also, let's multiply the second equation by a so that we can get also a times b times c at the left side of the equation, and multiply the third equation by b both sides to arrive at ABC equals 800b. Notice now that the left sides of these three equations are all a times b times c, and they're all equal. This means that the right sides of these three equations must also be equal. Now to simplify, let's compute for the least common multiple of 200, 700, and 800. 200 is 2 times 100, 700 is 100 times 7, and 800 is 2 times 100 times 4. We line up the common factors. So for the LCM, we have 2 times 100 times 7 times 4, which is equal to 5,600. Then let's divide each of these terms by 5,600 to arrive at this form. Then simplifying, this first part is equal to c over 28. We can simplify the middle as a over 8, and the right side is b over 7. Then let's rearrange this in alphabetical order. So we have here a over 8, which is equal to b over 7, which is equal to c over 28. And all of these must be equal to certain constant k. So each of these can be equated to that constant k. This enables us to represent the equation in terms of the variables a, b, and c. So using the first equation, we have a equals 8k. For the middle equation, we have b equals 7k. And for the third equation, we have c equals 28k. We want to find the value of a squared plus b squared plus c squared. So all we have to do is square this first equation, square the second equation, and square this third equation. The result would all contain k squared. So let's solve first for the value of k squared before squaring all of them. So to solve for k squared, notice that we have here a times b equals 200 as one of the given. But we know that a is equal to 8k and b is equal to 7k. That is equal to 200. Simplifying the left side, that becomes 56k squared equals 200. Divide both sides by 56 and reduce to lowest term to arrive at k squared equals 25 over 7. We do not need to express this in terms of k because when we square a, we'll arrive at an expression containing k squared. The same thing when we square b and c. So let's remember this value for k squared. Squaring now a, we have a squared equals 64k squared. Square b to get b squared equals 49k squared. And squaring c, we have 784k squared. The 784 is 28 times 28. Now, we have a squared, we have b squared, we have c squared. So if you add a squared plus b squared plus c squared, that is just the same as adding 64k squared plus 49k squared plus 784k squared. So let's carry that out. This is now the result. They are all like terms with variable k squared as the common variable. So we can now find the sum of these like terms, and that is equal to 897k squared. Because 64 plus 49 plus 784 is 897, and we copy the common variable k squared. But what is the value of k squared? We said k squared is 25 over 7. So let's replace k squared by 25 over 7. And simplifying, this is equal to 22,425 over 7. And so, for our final answer, the sum of a squared plus b squared plus c squared in this problem is 22,425 over 7. Thank you very much.